Hello everyone, welcome to the another new chapter of the 12th standard, the solid state. This is the first chapter of chemistry in 12th standard. I know most of the students have already studied this chapter, but no worry, you can do revision that will help you to build basic knowledge. Let's have a quick introduction. Solids have definite volume, shape and mass due to the short distance between the fixed position of the particles and strong interaction between them. As you can see in this picture, solid, liquid and gases. In the solid structure, particles के बीच में कोई भी space नहीं है, and you can see in the liquid particles पे थोड़ा space है, and in the gases there are lots of space. हमने सॉलिड क्या होता है ये तो देख लिया. सो लेट्स मूव टू द सॉलिड स्टेट्स. सॉलिड स्टेट इन केमिस्ट्री इज द स्टडी ऑफ स्ट्रक्चर, properties and the synthesis of solid materials. It is also sometimes called as material chemistry. It basically helps us to understand the compound from a molecule level to the crystal structure level. Let's move to the types of solid state. Based on the arrangements of constituent particles, solids are classified into two states, that is crystalline state and amorphous state. So first we will see crystalline state. The solid states are classified into two types, that is crystalline solid and the amorphous solid. So first we will see the properties of crystalline solid. These are the properties. They have sharp melting point and starts melting when it reaches a particular temperature. The shape of crystalline solids are definite and having typical arrangements of particles. They have definite heat of fusion, that is amount of energy needed to melt a given mass of solid at its melting point. Crystalline solids are anisotropic. What is anisotropic? Their physical properties are different in different directions. So crystalline solids are anisotropic. Crystalline solids are true solids. So we have done with our properties of crystalline solids. Let's see the types of crystalline solids. On the basis of nature of intermolecular forces or chemical bonding, crystalline solids are further classified into four categories. That is molecular crystalline solids, ionic crystalline solid, metallic crystalline solid and covalent crystalline solid. In this video, I will be explaining molecular crystalline solid. In the molecular solids, the constituent particles are molecules. They are further subdivided into three types, that is non-polar, polar and hydrogen bonded molecular crystalline solid. So first we will see the non-polar. These solids are formed from molecules that share a non-polar covalent bond, as you can see in the picture. The physical nature of non-polar solids are soft. They don't conduct electricity, it means they are insulators. They have very low melting point, and the example is H2 and Cl2. As you can see in the picture, at room temperature and pressure, they are liquids or gases. The force of binding the molecules together in their solids are called as van der Waals forces. What is this force, van der Waals force? I am not going to explain it in a detail, but you should have some basic knowledge about it. So, as you can see in the picture, attraction of intermolecular forces between the molecules are the van der Waals forces. Next is the polar. In this solid, the geometry is such that one side has a negative charge and the other side has a positive charge. आप लोग ये एग्जाम्पल में देख ही लोगे. And the force holding them together is a dipole-dipole force of attraction. As you can see in the picture, positive and negative charges attract each other. Next one is the hydrogen bonded. So in this kind of solids, the intermolecular forces are strong hydrogen bonds. They exist as a volatile liquids or soft solids at room temperature and pressure. As you can see in the picture, their boiling and melting points are higher compared to the both polar and non-polar. Next one is the ionic crystalline solid. So let's see the simple properties of ionic. These three are the properties of ionic solids. First one is constituent particles in ionic solids of the crystalline solids are anions, that is negatively charged, and cations, that is positively charged. An ion is surrounded by typical number of opposite charges. They have high melting and boiling points and are soluble in polar solvents but not in the non-polar solvents. As you can see in the picture, for example in NaCl, the Na positive ion is surrounded by the Cl negative ion, that is chlorine ions. Ions in these solids are held together by strong electrostatic forces. Next one is the metallic solids. In these solids, the constituent particles in metallic solids are metal atoms, which have valence electrons to be given or lost, therefore ending up being positively charged. The attractive force between positively charged ions and sea of electrons is cause for metallic bond formation. What is sea of electrons? You will see in the picture. This is force holding the metal ions together. They have high thermal and metallic conductivity. Last one is all metals and alloys are metallic solids. Next one is the covalent crystalline solids. Next one is the covalent solids. So let's see the properties of covalent solid. First, covalent solids are a class of extended lattice compound in which each atom is covalently bonded to its nearest neighbors, as you can see in the picture. This means that the entire crystal is in effect one giant molecule. And because there are no delocalized electrons, covalent solids do not conduct electricity. And last is they have high melting points. In this video, I have explained the classification of crystalline solids, that is molecular, ionic, metallic and covalent. I hope आप सबको समझ आया होगा. In the next video हम देखेंगे amorphous solid. So तब तक आप लोग रिवाइज करें and wait for the next video. Thank you and happy learning.